For decades, air combat was defined by visibility, speed, altitude, turning radius, missiles fired from within sight. But modern air warfare no longer begins with visual contact. It begins with data. Today, aircraft like the F-35 are designed around a simple principle. The side that sees first and processes information faster controls the engagement. The F-35 is often described as the most advanced stealth fighter in the world. But its defining feature is not its shape. It is its architecture. The aircraft was not built merely to fly. It was built to compute. And that distinction marks a turning point in military aviation. The F-35 program represents one of the largest multinational defense efforts in history. More than a traditional fighter replacement, it was conceived as a common platform across conventional runway operations, short takeoff and vertical landing missions, carrier-based deployments. Its design integrates stealth shaping, internal weapons carriage, and advanced avionics. But what separates the F-35 from previous generations is sensor fusion. Instead of presenting the pilot with separate radar, infrared, and targeting displays, the aircraft merges information into a single synthesized picture. The pilot does not manage individual systems. The aircraft manages them. This shift changes the pilot's role from operator to decision maker. The aircraft processes. The human decides. That division of labor defines modern air power. The F-35 reflects a broader transformation in warfare. Air superiority is no longer defined purely by aerodynamic performance. It is defined by networks. The aircraft carries millions of lines of software code. Its computing systems process enormous volumes of data in real time. Radar signals, infrared imagery, electronic emissions, link data from other platforms. This creates situational awareness that older fighters cannot replicate. But this also introduces a new vulnerability. Software-driven warfare depends on cyber resilience, electronic protection, secure supply chains, semiconductor access. The battlefield now extends beyond the sky. It includes microchips, clean rooms, and digital infrastructure. If air combat has become algorithmic, then dominance depends not only on engines and airframes, but on computational ecosystems. That makes this phase fragile, because digital systems evolve rapidly, and rapid evolution produces uncertainty. The most likely trajectory is gradual integration rather than dramatic disruption. The F-35 operates not as a lone platform, but within a network. It can detect targets and share information with other aircraft, naval vessels, ground systems. In this structure, the F-35 may act as a forward sensor node, less a solitary dogfighter, more a coordinator within a distributed architecture. This enhances survivability and flexibility. However, it also increases reliance on connectivity. And connectivity introduces complexity. Complex systems tend to generate new forms of friction. But in the near term, integration strengthens deterrence rather than undermines it. Stealth is not invisibility, it is reduction. Radar cross-sections can be minimized, but detection technologies also evolve. Advances in multi-static radar, passive detection, and AI-assisted signal processing suggest that stealth platforms will face increasingly sophisticated tracking methods over time. Whether these systems can reliably counter fifth-generation aircraft remains debated. But the broader pattern is clear. Detection and concealment evolve together. The F-35 represents a step in that cycle, not its conclusion. If detection improves, aircraft must adapt. That adaptation could involve unmanned companions, electronic warfare enhancements, greater standoff range, which leads to the next phase, The United States is developing next-generation air dominance systems. These programs aim to integrate crewed aircraft with autonomous wingmen. They emphasize longer range, greater automation, higher cost per unit. Early estimates suggest these future platforms may be significantly more expensive than the F-35. In high-intensity conflict, cost becomes strategic. Quantity remains relevant, even in an age of precision. This suggests that the F-35 is unlikely to disappear quickly. Instead, it may function as the backbone of Allied air forces for decades, with more advanced systems operating at the margins. The result is layered air power rather than replacement. It is unlikely that the F-35 renders air combat unstoppable. No system in military history has achieved permanent dominance. It is also unlikely that dogfighting disappears entirely. While long-range engagements dominate planning, close-range encounters remain possible under certain conditions, and it is unlikely that software eliminates the human factor. Despite automation, pilots still operate under extreme physical and cognitive strain. High G-forces, compressed decision cycles, ambiguous signals. Technology supports decision-making. It does not remove responsibility. Throughout aviation history, dominance shifted in phases. First, propulsion. Then, maneuverability. Then, precision munitions. Now, information processing. The F-35 reflects this transition. Its engine remains powerful. Its stealth remains relevant. But its defining characteristic is data fusion. The aircraft represents a move from mechanical advantage to computational advantage. That advantage is powerful, but it depends on infrastructure, and infrastructure can be contested, which means superiority today must be continuously maintained, not assumed. The F-35 is not unstoppable. It is optimized. Optimized for a battlefield defined by sensors, networks, and compressed timelines. Its real strength lies not in speed or raw maneuverability. Lies in information dominance. But information dominance is not permanent. It exists within systems that evolve. As detection improves, stealth adapts. As algorithms accelerate, counter-algorithms emerge. The F-35 represents the current balance point in that cycle, not the end of it. And in modern warfare, the most advanced platform is not the one that cannot be challenged. It is the one that adapts fastest. The future of air power will depend not on a single aircraft, but on how effectively nations manage the fragile intersection between software, hardware, and human decision-making. Because in the era of data warfare, control matters more than spectacle, and adaptability matters more than claims of invincibility.